Disclaimer: I'm not a professional, so the following video might contain incorrect use of terminology. So apparently people got interested in the 3D structure of molecules, and when things like this happens, they'll probably get worked up, do a ton of research, find the answer, and contribute to textbook material. So now before someone says something like, why don't we just use a microscope? No, you can't. Well, you couldn't. You weren't able to. The thing is, atoms are so much smaller than visible light's wavelength that it can't quite reflect light for us to see, and people then didn't have the necessary technology. Before hopping into today's topic, let's talk about the structure of an atom. An atom has a nucleus that's positively charged, and there are electrons zooming around it. The electrons that zoom around at the outer layer are called valence electrons, and those are the ones that will bond with other atoms and do stuff. So now we can start predicting the shape of molecules based on the fact that like charges repels each other and opposite charges attract each other. Eventually, this will form a stable structure where all the pushing and attracting forces kind of cancel each other, resulting in the molecule structure. Let's consider a simple example where there's a center atom with other atoms surrounding it. Take ammonium as an example. Its structure is a nitrogen atom surrounded by 4 hydrogen atoms. The electrons repel each other, so we can assume that the bonds will stay as far as they can from each other, resulting in this structure, where the hydrogen-nitrogen-hydrogen angle is around 109.5 degrees. Now let's look at another example. H2O, which is made of an oxygen atom with only 2 hydrogen atoms at its sides. But there are also 2 pairs of electrons that aren't used for bonding, which are called lone pairs. The position of the electron orbits should be somewhat similar to ammonium, but the angle between the lone pairs will be bigger, and the hydrogen-oxygen-hydrogen angle will be smaller, resulting in this structure. Of course, most molecules aren't as simple as those mentioned, but we can still use the same principle and some help from computers to predict their structure, and most of the time our results are correct. Most of the time. That said, those are only an assumption of what the molecule should be like. Therefore, we'll have to prove it. But that won't be covered in this video because I don't know how. And that concludes this video. Thank you for using your precious time to watch this video. Nah, just kidding, I haven't reached the 5-minute mark yet. Now, we're going to talk about some ways to actually determine molecule 3D structure. So one of the ways I'm aware of is using X-ray diffraction. So if there's a crystal that's made of the molecule we are interested in, we can use X-ray diffraction. So this works. So the crystal, you can view it as a lot of layers of atom, all parallel to each other maybe. And then we can shine X-ray on it. Now when the X-ray reaches the first layer of atoms, some of the X-ray will be reflected, but some of the X-ray will pass through the first layer of atoms and reach the second layer. Now at the second layer, the same thing will happen again, so like this, and then some of the light will pass through and go to the third layer. Now this repeat and go on, and this will sort of form a lot of different paths of light, and that will cause diffraction to happen. And shining X-ray at the crystal at a different angle will produce different kinds of diffraction patterns, so we can then analyze them using magic, by which I mean stuff I don't understand yet, and we'll be able to recreate the structure that caused the diffraction. If we're dealing with gases, we can use gas electron diffraction, which I ain't gonna talk about because my eyes are tired from staring at Wikipedia. Thank you for using your precious time to watch this video.